You can either upload the data directly from the microscope with the DECTRIS Cloud Sync, or in my case, I already have uploaded them after acquisition in the data folder, and here we can see the experiment. The raw folder contains all my TIFF frames, and unfortunately I did not save the gain reference. So to calculate the gain reference on the fly, let's make a job template. Choosing the Reline environment with all the Reline tools already pre-installed, we can simply access the Reline commands. And the job is basically just a bash file that has access to environment variables that the user can give as input variables. So let's remove all this and let's add a quick import job for Reline, and then we can run Reline estimate gain. When the script is done, we simply can make a job template out of it, and this job template is now reusable on any kind of data set you have. So let's run it on our raw data. For this, I'm going to choose a machine with 32 cores. And it's running. While it's running, we can quickly check out the output log to see if it's actually doing what we want, and it looks promising. It detected 3,500 movies and it's starting to sum up the frames. In the meantime, we can already go ahead and start a CryoSpark session. That means we'll choose the CryoSpark environment and choose a GPU performance node we want to use. Mount the dataset and start the session. Let's have a quick look at the job. It is completed. It produced a gain.mrc. If we go to the folder structure, we can see that there is also the output log. And now we can use this gain reference in our session. Once the session is running, we can simply click on Reconnect and it will open a new tab with our Ubuntu workspace. In the case of the CryoSpark environment, it will prompt you for your license key, and once you give it to it, it will set everything up automatically. Once CryoSpark opens in the browser, you can simply log in and go about your project as you would normally do using CryoSpark. You can always find your mounted data under /DECTRIS data, the year, and then your project identification numbers. And then we can import the movies straight from the raw folder, which contains all our TIFFs. The gain is the result of our job, which we find under the processed folder. For this dataset, it took me about 6 hours to go through all the different steps and end up finally at a 2.3 angstrom structure that we can have a quick look at in the CryoSpark browser. And then we can simply download the final map and make sure that it finds its way to the DECTRIS data subfolders where we can use it for jobs or other sessions down the road. Here we can see the same density file in the work directory. And what I want to do is I want to automatically build a model into this density map. For that, there's already a public job template that runs Reliance Model Angelo. And we just have to give it the density map, choose a GPU node, and run the job. A few minutes later, it's done and we have our atomic model file. And we can now go back to a new session with a CCP4 environment that contains code to visualize the map and the model together. Finally, I can share the whole experiment, including all the CryoSpark workflow and job, with my colleague Camilla. And while I'm at it, she might actually find some use in the generate gain reference job as well. Hopefully it will save her some time.